record the session as well, so that you'll have the recording of the session. So some of you who might not be able to, get all the things properly because of a network issue, you can always go back and see the sessions. The recording of the sessions will be available on our YouTube channel. So you can certainly go back and go through the recordings. Okay. I hope you are able to see my screen. Are you all good on that count? Okay, I would like your response on the chat window. It will be helpful for me to make the session interactive, right? So if you're able to see the screen, you can just say yes or no, and we can be good about it. All right, great. So most of you people are saying that my screen is visible. So that's a go ahead that we can start with the session. Okay, all right. All right, guys. So my name is Kush, and or or my name is Kushagra. People call me Kush. I'm part of this company, Dimensionless Technologies, which I co-founded about 2.5, 3 years back, and we have been primarily working on this field of data science. Right. If you talk about my background, so I'm an IT Delhi graduate with about 10 years experience in the industry now, and quite a bit of that has been into data science and data analytics. Right. So I'll try and give you a lot of insight in this session as to what data science is, why we are talking about data science today, what is the need for data science. We'll try and understand if you're trying to transition to data science, what all things would be very, very important. How do you think about your previous experience, what you should do, and there will be various other things which will come into picture, right? Plus, we'll try and also give you the skill sets which a data scientist requires. So what all things would be very, very important. Who should try and get into data science, who should not get into data science. If you're getting into data science, what should be the approach? How do you move ahead in the in the procession, so that you are able to land up a job easily, and so on and so forth. So we'll be talking about a lot of things in the session today, and we'll try and make sure that we give you, we'll keep the questions towards the end. I'll maybe if there's a particular question specific to a slide, you can put that up then and there. I'll try and answer that. Otherwise, I'll have a lot of questions and answers towards the end of the session. I'll take all your questions. So there I'll ask you to unmute, and we'll be having a very interactive session. Okay. So on that note, let's get started. All right. So this will be the agenda for the session. We'll try and understand what this field of data science is all about, right? What is data science? Why are we talking about now? Why are we talking about it now? And then what are the important skill sets for a data scientist profile, right? And then how do you actually transition from your current role into a data scientist role? Who should transition and how should you transition? How should you take care of your previous experience? How you should work with the projects? What are the other skills which will be important? We'll be talking about all of that. Okay. All right. How many of you are aware of data science? Anybody on the chat window? How many of you are aware of data science? Know what data science is? Quickly. And whatever you know, you can just ping me on the chat window. Okay. For you, data science is XYZ. Okay. I would want a couple of words in which you can try and 3 or 4 important words in data science, if you can tell me that. Anybody? Data mining, okay. Machine learning, wonderful. Business data driven analytics, big data, okay. Big data and data science are two different things. I'll kind of explain that also. Tableau, okay. Statistics, R, Scala, Python tools, okay. Great. So I think many of you have given me predictive modeling. Wonderful, Siddesh. So predictive modeling, there are various things in data science, right? Let's try and understand what exactly data science is. Why are we talking about data science, right? It's correct, Shubham. That is decision making. So you're trying to take decision based on data. Okay, collecting and analyzing data with proper tool. Okay, so not really. To some extent, you're right. So we were collecting data, we were analyzing the data earlier as well, but that was primarily, if you talk of it, that was more of descriptive analytics. I'll talk about those as well. I'll kind of give you a differentiation between how the technology has evolved and why are we talking of data science. So I'll try and cover that point there. Okay, great. So let's get started here. So when you talk of this field of data science, right, this field of data science is primarily about finding patterns in your data, right? Understand, as a data scientist, your most important job is to take a set of data, gather the data, apply statistics on that data, and gather insights or patterns or information, whatever you may name it. Okay, so as a data scientist, okay, if you go one step further behind this, uh, the data science, if you talk of data science is all about business problem solving. Okay, data science is about business problem solving. You're trying to solve a business problem, right? That is the essence of data science. So as a data scientist, your job will be to solve a data business problem, and here what you're trying to do, you're trying to make sure that the decisions that the business is going to take, those decisions will be data driven. They will not be gut based, right? You're trying to predict stuff and trying to take a decision based on the data. Okay, so there'll be data driven decisions. Okay, now to be able to do that, to be able to solve a business problem, to be able to take data driven decisions, what you do in data science, you try and understand the business problem, right? You try and understand what are the factors which are affecting or impacting your business problem. Okay, so for example, if you take uh, if you take a uh, simple example of, say, it's a simple credit risk modeling only. Okay, this is something which is many of you can relate with. So or you can relate with e-commerce also, right? So in e-commerce industry, you have a problem. Say you're trying to understand how do you improve the customer conversion. So how do you make sure that whatever customer is trying to buy, you are able to give that to customer before he actually asks for it, right? So, or if a person is looking for some product X, or along with product X, what all things is he likely to buy, right? So you try and give some kind of combination, some kind of an offer on that, so the sales would increase it. There can be various kind of problems. So that's primarily a business problem that you're trying to solve. You have a problem where you're trying to say, okay, I need to improve the sales of some product X, or I need to think about improving the profit margins on some of the products, right? That can be a business problem. Now, to be able to understand how sales are getting impacted, or sales are getting impacted for that product X, right? You need to, there'll be multiple factors, multiple variables, multiple data which would be impacting your sales. Correct. So you need to be able to collect that data. You need to be able to fetch that data from wherever that data is residing. Okay. Similarly, if you talk of a telecom customer, right? So telecom, I am a telecom service provider like Airtel or Vodafone. I want to know, out of my so many customers, how many of my customers are likely to port to the other vendor, or are likely to give away my services, and uh, they take the rival services, right? So can I try and know, there'll be again certain factors, certain patterns which will tell me, okay, if the consumer is behaving in a certain way, the chances that he is going to switch to the rival company or switch to the next service provider is pretty high, right? So you start offering them something, trying to retain the customer. So pertaining to a business problem, as I said, which can be related to a simple a telecom provider trying to retain a customer, or it could be credit risk modeling, or it could be within finance, your fraud, trying to detect fraud for your credits, or you're trying to in manufacturing industry, you're trying to understand when your machine is going to go down, right? So you're trying to do preventive maintenance of your machine. I'll talk about a lot of those examples maybe toward a little later in the session. But data science is primarily about business problem solving, right? So why I'm trying to stress on that point here is, again, because data science is not really a very technical domain. Don't consider data science to be a domain where you're only talking of a lot of technical stuff. I'm sure many of you are coming from IT industry, and you would want to relate data science to the technology, which is true, and which it's not that it's not related. It is related in a certain way, but I'll talk about more about that as well. Okay. So before I go ahead, I'll quick check. I forgot how many of you are from IT industry, and within that, uh, within IT industry, what kind of a profile that you have quickly, so that again, the session becomes a little interactive. You're able to uh, tell me a bit more about it. Okay. Quickly on the chat window, 1 minute. Maybe if you are say working in ETL, you can say ETL, uh, IT sales. Okay, PHP. Great. SAP. Okay. Yeah, Siva, I remember you. Great. Uh, Verizon. Okay. Operations. Great. Uh, R&D, IoT, embedded software, ClickView. Great. So I have a lot of people from various, okay, business presentation specialists. All right. So people from various domains, right? People from various domains are in here, and you have various, varied profiles, right? And you're trying to. Somebody said he was a professor as well. Great. Siddhesh says he's working in, okay, know your customer domain, civil engineering background, currently working with know your customer domain. Okay, great. All right, fair enough. So I have a lot of different backgrounds in here. So probably it would be a good mix, and I'll have questions from various domains, and we'll be able to answer that. All right. Now, when you talk of data science, I was saying it is more about taking a business problem, figuring out what are the factors, what are the data which is impacting that business problem. Then you will have to process that data. Okay, you'll have to process the data. When I say you need to process that data, you need the data might be in the raw form, right? The data that you get will be in a very raw format. It is not directly you if you try and do the analysis on that raw data, whatever prediction, whatever patterns you might find might not really be all that great, and might not really be too close to your real real scenario. So if the idea is to be able to create a model, create a system, create an equation which is going to help you predict values, predict what is going to happen tomorrow, right? Now if your data is not good enough, if your data is is the quality of data is not all that great, the quality of prediction will also get hampered, right? So we would not really want the data to be unclean. We would want the data to be clean, right? To try and structure data. Also, as a data scientist, you'll have to work with unstructured data, and you'll need to know how do you handle unstructured data. I'll come to that in a while when I talk of skill set. So primarily in data science, you're taking a set of data and applying a lot of statistics on data, right? So statistics does play a very important role in a data scientist profile, right? It's a business profile. It is not really a technical profile, but statistics will play a key role in data science, right? And you'll be using a lot of algorithms. To be able to work with data science and to be able to predict values. Okay. Now, when you apply statistics on data, that statistics or machine learning algorithms, you will have to use some or the other tools to apply that. It's not that you cannot apply that with Excel. So Excel again can be a tool, right? You can use tools like Excel, like SPSS, MATLAB, R, Python, SAS, right? Various tools are available. I'm talking, so earlier we were using a lot of SPSS, MATLAB, a lot of Excel. But as the size of data has grown, right? As we are generating so much data, We are handling so much data these days. We're trying to predict with that much data. uh, Excel certainly cannot, is not good enough, right? Excel has a lot of limitations. So is the case with SPSS and MATLAB, which are again paid tools and are not really all that efficient. You can do that much easier, much simpler way with tools like R and Python and SAS. Okay, so as a data scientist, you're trying to solve a business problem by applying statistics on data. You're trying to find patterns, and to be able to apply that statistics on data, you need to know tools. Till this point, are you good? Anybody has any questions? I've just written that down in one single line. It's primarily a process of finding patterns in a set of data, right? Using which we'll be creating a model, right? That pattern is going to help you create a model, and that model is going to help you predict a value. Okay. As I said, you are trying to use statistics, so statistics will play a part. Again, there are two things to this now. When you talk of statistics in data science, the good part is the statistics that you have learned earlier, right? In your class 8, 9, 10th, or when you were mugging up a lot of equations and formulas in Excel. Now you don't have to worry about that. This is more of a conceptual understanding that you have to do on statistics. And when I say you have to do conceptual understanding of statistics, it's not really mugging up the formulas, primarily because now the tool is going to do all the calculation. The tool is going to fetch you the output. Your job will be to understand what that output is, to be able to interpret what the output of that algorithm is, of that statistical analysis is. Once you are uh, once you are once you're good with with interpreting data, with understanding of the algorithms, then you will be able to work much better in data science, right? So that will be a key skill, that will be an important skill. I'll come to skill sets again, but I'm just trying to give you a little bit of flavor here of the skill set as well, along with what data science is. Okay. All right, so I've mentioned here that statistics will be an important component of data analytics, and I mean, again, I'm trying to break a myth here. I'm trying to bust a myth here, and that myth is that a lot of people feel that when you're working with data science, when you're working with analytics, uh, you and many of you who come from IT industry, you have that kind of a mindset, or you have been told like that if you learn R, you become a data scientist, or if you learn Tableau, you can become a data scientist tomorrow, right? So that's certainly not true, right? So only tool will not be enough. Tool is an important aspect, tool is required, but that tool itself is not enough, right? You would need so much more other than the tool as well, right? And primarily statistics and machine learning would be far more important when you talk about a data scientist profile. Plus you need business domain, I mean the problem solving ability, the domain ability, and the other things, and the coding sense. There'll be a lot of things which will be required. We'll talk about all of that. What is data science? Is that clear to everyone? Siddesh, I'll answer those questions in a while, right? I'll talk about those questions. I'll certainly take that question. So when I come to tool, I'll take that question. All right, great. So are we good? Can we move on? Okay, somebody was saying about big data also. Um, you understand the difference between big data and data science? How many of you understand the difference between big data and data science? Anybody who does not understand the difference between big data and data science and feels it is one and the same thing? Okay, quick responses on the chat window. Uh, no problem. So I haven't talked about big data. Okay, a lot of you don't know the difference between big data and data science. Okay, okay, let me explain. Okay, fair enough. No problems. Let me explain the difference between big data and data science, right? Um, okay, just give me 1 sec now. I've taken away the screen. Just 30 seconds. Yep. All right. So I need a page to be able to explain that here. And all right, great. So see, when you talk of big data as a technology, when you talk of big data as a tool, big data is primarily uh, about handling data, right? So big data is primarily about handling data. What your job is to be able to manage the amount of data that we are generating, right? So you might be a big data engineer, you might be a Hadoop developer, you might be a pig and hive, and you know other components of big data or Hadoop ecosystem, which is Spark and other things. You might understand MongoDB or Cassandra, which are NoSQL databases used in parallel processing there. So big data is all about parallel processing, right? This is about parallel processing of data. And what does it primarily mean at a very high level? If I take the bird's eye view, big data is all about how do you store so much data, how do you store. And again, when you say big data, I mean, the amount which is big is varies, right? So I'll talk about that as well. So how do you store so much data, and how do you quickly retrieve it? So storage and retrieval, right? Both of that are important aspect of big data. So entire big data as a technology is focused on these two things. So much data being generated, right? So if you talk of 1995 or 2000, there, we were working with CDs, right? That was only about, say, few MBs that you could work with, right? There, if you talked about, say 10 GB of data, that was considered huge. 10 GB was huge data when you talked about 2000, 2002, 2005. As you moved on, now today, one TB is also nothing, right? So big data is data which you are able to not really process at any given point in time. So that much data which one single machine is not able to process, that certainly starts falling into big data category. So big data is a very technical profile here. Your job is to be able to handle all this data, right? Now you have collected so much data, right? You stored and retrieved that data, but this data in itself would not mean anything. The data in itself is of no value, right? Data does not contain value. You will have to find value out of this data. You have to make this data talk. You need to make this data useful, right? You'll have to extract meaning from data, which I was talking about here, right? You need to extract insights from data, and that insight has to be, to be able to find that insight or predict values, create models. That is what data analytics or data science is all about. Okay, analytics is, I should not use the term analytics, rather I should use the term science here. Analytics per se is only one component within data science. Uh, okay, I'll talk about that also if you have confusion. So big data is all about storage and retrieval of so much data which you are generating. So you need parallel processing. You are trying to put data into clusters, and you're trying to retrieve data. You're trying to send your code to different machines, getting the output there, again combining all of that and giving it out, right? So there's so much more to it. I'm talking at a very high level. In terms of data science, it's not about handling data, it's about processing that data, it's about finding meaning from the data, it's about uh, using that data to some or making that data useful, right? To be able to help you improve business. Is it clear what big data is and what data science is? So data science is more of a business field where you're trying to use the existing data to improve the business. Okay, and you're trying to find patterns or meaning out of that data. All right. Now, various types of analytics there that are present here, right? So if you talk about it, uh, okay, before I talk about it, let me talk about this first, and then within that I'll come to this also, right? So now let's talk about this. So why are we talking about data science, right? Why is it that data science has gained a lot of popularity now? It's not that data science is new, right? If you go back and look at the usage of data science has been in use. The predictive analytics has been in use for many years now. Okay, and BFSI, the banking and financial services industry, they have been using it from, say, since 1960s, 70s, right? The only difference is that, again, they were the amount of data that they were working with was pretty less, and there they were making statisticians sit on in front of systems, and statisticians were doing it. So the jobs were few and far between, and you really needed a lot of business acumen and statistics concepts back then if you were trying to become a data scientist, right? Or if you're working in that field of data science. So for fraud detection, for a lot of such applications, banking and financial industry has been using data science. Plus, if you talk of tools, like if you say Python has been there for ages. Although Python has been developed for data science in the recent past, R has been there since 1995, 97. Openly available since 1997 for you to be able to do analysis, right? Why is it that we are talking of data science now? Anybody, any idea? What has changed? Correct? Anyone? What has changed in the recent past that is making us talk about data science today? Lot of data. Okay. Lot of data. Okay, one thing is we are generating so much data. That's one part. Okay. And okay, the volume of data is one part. And just to let you know, right, when you talk of volume of data, many of you will think that the amount of data that we are generating is because of the social media and and a lot of digitalization which has happened. That is true. But a lot of data that we're generating is because of IoT, and that is because of machine to machine interaction. There are a lot of logs which are being generated, and uh, and that is what is resulting in a lots and lots of data generation. So still about 80-90% of your world's data is in logs, right? Your entire e-commerce and YouTube and social media, all of that taken together might be about 5-7% of data, and rest is the other data. So it's not just about that. There are so many things which I've also advent of IoT, right, which is Internet of Things, which is machine to machine interaction. That is one source where we're generating hell lot of data. So one point is that we certainly are generating a lot of data today. That's one thing, right? What else? There's a need for this to do more things in a short span of time. Okay. What else? Trying to predict to get more insights. Okay. Lot of information. Okay. What else? Prediction. Okay. All right. So see now, why are we talking of prediction? We're trying to, okay, unstructured data, correct, Venkatesh? So we're trying to work with unstructured data as well. That is also one of the reasons. All right, let me try and give you, a little more into why we're talking of data science today. So see, data science as a field has been there for, okay, bang on. Uh, okay, okay. I get a lot of good pointers here. So he says, Ankit says that the business is needed, right? Business information is needed, right? So businesses have been using data. If you have heard of the term business intelligence, right? Or if you have heard of the term reporting, right? We have been doing that for over 10 years now, right? And how that works, I'll just draw a quick chart here. So again, there also, if you talk of reporting or business intelligence or data warehousing, right? So in what happens there, you have data, raw data, right? You collect that data, you clean and transform this data. Sorry, clean and transform. bear we Bear with me for my writing here. I'm just trying to scribble. So cleaning and transformation of data, I meant cleaning here. Raw data, you cleaning and transforming the data, putting that into data warehouses. On top of it, you run your BI engine, right? And when you run your BI engine on top of this data warehouse, what you get some kind of report, right? And this report, uh, okay, sorry about that. So Ankit says I'm writing like a doctor. Okay, so I'm just trying to scribble quickly. Sorry about that, Ankit. So I'll try and do that better next time. Okay, so raw data, you try and clean and transform the data, and once the data is cleaned and transformed, you put that into warehouses, right? If you are anybody from ETL, BI, DW, that kind of background, you would understand better, and you run reports on your data warehouse or this engine, and once you run your BI reports, the or run your BI on this data warehouses, you'll be generating reports, and these reports are going to tell you what has already happened. Okay, what has already happened or what is happening now. Okay, these are the two things that you are primarily concerned with. So the erstwhile BI that we have been using, even now we are using it. There we are only trying to figure out what has already happened and what can happen, what has already happened and what is happening today. You don't know what can happen tomorrow. We were not talking about it till now, right? Most of the businesses were not talking about it, right? Now, what is the need to talk about these things now, right? Why are we talking about tomorrow? Why are we saying that we need to predict? So one of the very important reasons why we are saying that we need to predict the values today, we need the output tomorrow. Many of you come from IT industry as well, right? So have you heard of this term value adds in your projects? Has your manager or your client been after you to give you value adds so that they can improve the efficiency of your system? Has that been happening of late or in the past uh, few years, 2 years, 3 years, 5 years? Has that happened with you? Yes, yes. Many of you are saying that has happened, right? And why that is happening? Because the businesses per se, right? Businesses need to grow, right? Businesses need to improve their top line and bottom line, which is their revenues and their profits, right? So if the businesses need to improve their profits and revenues, there have been various eras, right, which has helped businesses grow. So you talk about industrial revolution, right? Because after which the businesses boomed. Industrial revolution came in, then IT revolution came in. Within IT, if you talk of, because we are from IT revolution, or we from that era. In IT revolution, you started with simple Excel eras, right? You were working with Excel and improving efficiency. Then you said, okay, this is not enough. We need to have one instance of data for everyone. So you came up with ERP systems, right? ERP systems came into picture. Then to handle client, CRM systems came into picture, and integration happened. Legacy systems you're trying to improve. So many things. You had mainframes in there which were huge, right? Mainframes which are trying to process a lot of data at a very quick rate, right? So a lot of things was happening earlier. Because of all this out, there was a lot of improvement in the efficiency for the businesses, right? Over a period of time that happened. Then you suddenly stopped, right? In the past 3 years, 4 years, 5 years, if you see, there hasn't been a lot of improvement, right? The IT per se, the existing technologies have more or less stagnated, right? And if you look at the numbers of many IT companies, you would see that their numbers have more or less pretty subdued, right? So what you're trying to do now, you are trying to improve the efficiency of your business, right? So you're trying to predict values because you want to improve the efficiency of your business. Okay, so if you want to improve the efficiency of your business, you're trying to use the newer technologies, newer things like analytics, uh, like big data, right? So these, or IoT, or artificial intelligence, or uh, AWS. You're using so many things now, right? You're trying to make sure that you get more value out of your existing data, right? That is where the focus has been. Now, to be able to do that, you're trying to predict values. You're trying to see, can that value add which you were talking about, right, that the client was talking about, if you talk about the value adds, this analytics is helping you get those insights. Those insights are nothing but value adds which are adding value to your business, right? They're improving the efficiency of your systems. Maybe if you're able to retain a customer, you are improving sales, right? If you're say trying to prevent the machine from breaking down, you're again saving a lot of cost there, right? So everywhere there's a lot of cost which is attached to a lot of things, and you're trying to improve upon that, right? So we're talking of data science primarily because the existing technologies has more or less got into a place where it is difficult to improve much or improve significantly on your existing efficiencies, and thereby we're looking into other technologies. We're trying to predict values, and where their data analytics plays a very important role, because it will give you some important nuggets which are not really visible to you directly. Okay, so that's one of the reasons. Now, uh, with more data being generated, right? If you're generating more data, that will also help you in better prediction, right? So if I told you earlier you were trying to predict, but the prediction accuracy, the amount of things you could do with that data was pretty limited, right? With more data coming in, the accuracies has gone up. You are able to solve more business problems. So what I really mean is that, so if you had one set of data, it was able to answer only say 5 questions for you. Now you have, so you can combine that data with 10 other data points, and once you combine that data with 10 other data points, now this set of data which was here, now it is able to answer 10 more questions. So earlier it was only say 2 questions, now you are able to answer 10 more questions, right, with that. So you're trying to use that to improve, uh, to improve the uh, improve the business decision making, to be able to improve uh, uh, the overall uh, efficiency of the business, right? All right. uh, okay, then you have, I talked about parallel processing, I talked about increased competition, right? So businesses are trying to grow. Then you have need to improve productivity and efficiency. Again, I've talked about all these points. And then and okay, inability. And then you have also one more important point, and that is that you have a lot of computing power, right? The computing power has gone up many folds. So because of the increased or advanced computing power, you are able to do so much better now, right? You can predict better now. Okay. All right, now just come to this types of analytics that we have, and then we'll move to the next thing, right? So if you look at this, till now the businesses have been reactive, right? We have been very reactive, which was, we were trying to do descriptive analytics, we were trying to understand what has already happened, right? And then now the business, and we were also trying to know why something happened, right? Okay, this happened, why did it happen? You're trying to infer something about it to some extent, and you are making sure that the business is ongoing, you are able to create profits, and you are able to work with that, right? Then uh, now the industry is changing, right? Now you want to be more proactive, you want to do a lot of predictions. Okay, you want to be predictive, right? Now the shift has, there's a, sudden shift here, right? From this part, we have kind of come in here. Now we are saying, okay, I know, or you have created reports, and you know what some area is or some sales territory is performing pretty good, some are not performing good, and you also know why that is happening to some extent. Now you want to know, is my certain sales category going to do better next year or not, and what are the factors which are impacting it? Can I come up with some kind of insight which can help that territory do well next year? Or what kind of changes can happen in the next course of next year, because of which I need to take some proactive steps and improve or change certain things in my business, because of which my efficiency will improve, or my business will grow. So you have started thinking in those lines, right? The businesses have started thinking in those lines now. Okay, and that is where there's a need for predictive analytics. Everybody is good with that till this point? Any questions, confusions? Yes, no, quickly on the chat window. You've been very responsive. Many of you have been responding continuously. Great. Okay. Yes, we are good. Okay, fair enough. All right, so let's get going. Okay. Now, now let's talk about what are the skill sets which are required to become a data scientist, right? Before I talk about the skill set again, I'll can kind of break that into different things. But I would want to tell you one important aspect here, and that is, if you're trying to get into data science, or you're trying to get into a data scientist profile, right? Trying to get into this data scientist profile, uh, I told you this is, there are various things which you need to consider, right? One is, as a data scientist, you need to know a bit of business, right? So a bit of business acumen will be required, right? How do you get that? I'll talk about that in a while. Then you need to be somebody who likes problem solving. Okay, and when I say problem solving, I mean, how do you know whether you like problem solving or not? I mean, I'm saying, okay, Do you like problem solving? You say, okay, I solve a lot of problems on a daily basis in my organization, right? I try and do firefighting all the time. So do I really mean only that, or are you somebody who likes challenging stuff? So when I say are you somebody who likes problem solving, what I really mean here is that are you somebody who's analytical in nature? And if you're doing firefighting on a daily basis, you're solving a lot of problems on a daily basis, certainly you're somebody who likes it, right? The other way, those who are not really of that bent, or not really facing on a daily basis or on a regular basis, how you can check whether you like problem solving or not, right? So are you somebody who likes logical questioning? If I give you logical puzzles or logical reasoning questions, are you somebody who has that curiosity to go, uh, you know yeah, curiosity to go ahead and solve that business problem or solve that puzzle, right? So there has to be an inherent quality of problem solving, and why that is required is because data science, there'll be a lot of business problems which will come your way, right? And every day will be I mean, same business problem with a different data is a very different business problem, right? I mean, to be able to solve that business problem, you'll have to do so much more, right? Or you might have to do think so much differently, trying to solve a same business problem, but with a very different set of data. So data science is a lot to do with your ability in terms of your you know being there and attempting things. So it's not that you'll get an answer in 5 minutes or 10 minutes, right? You have to be at it for quite some time. Many a times you'll have to be at the problem. You have to think through the problem. You have to, keep working on the problem for much longer than you really, wanted to do it, or than you expected earlier. So those things are something which will be very important. So if you're somebody who is keen on business problem solving, who is keen on analytical things, who is keen on logical reasoning things, who is curious about problem solving, and every business problem is like a data, a logical reasoning problem, right? You have to think through that problem and get to the solution. Okay, so that will be an important aspect. Then you need certain technical skills, and then you need certain um, business skills, right? So in terms of business skills, problem solving would be important. Business acumen will be important. You need to understand the business communication, right? You need to be able to communicate your results. So in terms of some reports or dashboards that the business would understand, right? Um, Plus in terms of technical and mathematics or statistics knowledge, right? All these will be important as a data scientist, right? This is something which I cannot teach you, right? Are you somebody who likes problem solving or not? This is already decided, right? Either you like it or you don't like it. With your so many years that you spent, learning things, doing things, by now you have developed a habit. Are you somebody who really likes problem solving or not? I'll talk about all these skill sets later. I'm primarily focusing on problem solving now. So I'll come to that, right? So that is something which I cannot teach you now. That is very difficult to inculcate. I can do it, I can try it, and in our course we do try to make sure that you learn everything through problems and case studies, and that is where you start thinking about things, right? So we try and make you think analytically also. So that is something I can try, right? But it's something which is very very difficult to create in a very short span of time. That is a habit that you have developed over a period of time. Either you're somebody who likes a lot of it, or who is okay with it, or somebody who's very averse to it. If you are very averse to problem solving, logical reasoning questions, analytical questions, uh, you know then data science might be a little difficult for you. If not, if you're somebody who's keen on these things, data science could be a wonderful career option for you. Okay, it could be a, a, a career which could be very fulfilling as you move ahead. And why I'm talking about that, and why you can choose data science as a career, because this field is only started, right? There is so much happening on a daily basis in data science, and there is so much to learn, that even if once you become a data scientist, it's not that the field will be static and you are nowhere, right? Your job will be lost after 3 months or 1 year or 6 months. The technology will grow, the technology will evolve. There'll be a lot of changes which will happen over a period of next 10 years, 20 years, but you'll have so much to learn, and so many things to grow, right? So that is something which can you can certainly look forward to. Okay. All right. Now let me talk about the other skill set that we were talking about. Okay. So coming back here. So now I'm trying to, bifurcate this into three things. I'm saying three things, two or three buckets where I'm trying to put all of this. So one I'm saying is the domain understanding, right? Domain understanding is the knowledge of the processes of the business of the industry that you are working in. Okay, so you might be working in manufacturing domain, so you understand that process. Somebody might be working in supply chain, he might understand that. If you might be working in, say, so within IT, you're trying to service a telecom giant, right? You understand that part of it, so on and so forth. Somebody might be working with oil and gas industry, so he would understand the processes, the pain areas, the problems that industry is facing, right? And once you have a clarity on the kind of problems that business is facing there, then you'll be able to uh, do so much more with that problem, and you'll be able to solve that problem in a easier or better way, right? So when I talk of this, I'm talking of the business skill sets. So this is a little of a business side. You need to understand the domain. If you know the domain, that will help you crack the business problem, to be able to empathize with the business problem, to be able to understand the business problem. And when you do that, when you have to do all of this, domain knowledge will be very, very handy. Okay, that's one thing. Okay, so domain knowledge is nothing but the knowledge of the value chain, how the data flows, how the processes are, what steps happen. So for example, utility industry, say if I just take a simple example of say electricity generation, right? Or electricity, or utilities, right? Power utilities. So what happens, there must be a electricity generation, where it is electricity is generated, then the electricity is sold in the power exchanges. Somebody will buy, somebody will sell. Then it is transmitted. So then the electricity is transmitted uh, to the transmitters, right? So they'll be transmitting it. Now, once that is, then they'll be transmitting from the generation point to the end point. Then the retailers will buy it. And then the retailers will be selling it to the end consumer. So there can be various people in that value chain who might be doing so many things. And if you understand the processes, the business concepts of that, you would, if I tell you some, how you can use analytics in power utilities, I'll come. So that's a very good thing that just struck me. I'll give you that example. That's a wonderful example. How the entire business, business scenario change, how the entire business, you know, uh, the business proposition or the business models are being changed by entry of newer players, right? And they're disrupting the market big time. So I'll talk about one example a little later on power utilities. Okay. Ah, all right, coming back here. So domain will be the understanding of the business. If you know it, that will help. If you are pretty fresh in the industry, not really spent a lot of time, people would not really expect a lot of that from you, because you've not really been too deep into it. But if you really want to know a bit more about domain, I would recommend you go back and go and read a few white papers on some of that is present on our okay, that's a restricted site. So on our learning management system, we have kept a few white papers which are pretty good, and give you a lot of insight about a certain industries. And those papers are not something which we have created. They are readily available over the net also, on various consulting websites. So if you go to some certain consulting companies websites, you'll be able to get your hands onto some of this. So if you're really keen on learning about a certain industry, you can always go and read that up. But if you're not really too experienced, there will be others who will be able to assist you. So for example, uh, a business analyst, right? In many of your technical projects, you have a business analyst who understands the business parts and gives you the technical aspects of it, right? He acts as a bridge between the business and the technical team. So because and that business analyst understands the business domain much better than you do, right? So on and so forth. So there'll be people, domain experts will help you, but if you know it, you're not really dependent on others. So in your overall profile, that counts to about 10 to 15% of the overall things, right? Overall scheme of things. Again, if you are experienced, if you're not experienced, 1 year, 2 year experience, that will not really have a lot of weightage in your profile, right? When you put it out for somebody to look at. All right. Okay, so that's one thing. Now, in terms of technical things, you need to know the few things which you must know, right? So, statistics is something which you should know, right? This is must have. You cannot say that I don't know statistics. And again, I told you this. The good part is you don't have to, uh, you know, you don't have to do the derivations. You don't have to uh, solve the problems. You don't have to mug up the equations and mug up the formulas and do the solving on your own. It's certainly not possible by hand also. You will be using tools. The tools will be giving you certain outputs, and you'll have to understand what those outputs are. But to be able to understand that, you need to know statistics from the scratch, right? So there's something called descriptive stats, which is very basic statistics. I'm sure most of you have learned that in your class 8, 9, 10th, 11th, somewhere you've done it, right? And you, if you remember some kind of distribution, normal distribution, uniform distribution, your variability of the data like standard deviation, what are mean median modes of your data, right? To be able to understand data. So descriptive statistics will help you understand each variable. So I was talking about various variables. So say if I take um, this simple credit risk modeling example again. So suppose you want to understand whether my salary, or if you want to understand how salary of of say 20 lakh people whose data you have varies, right? And what kind of data you have for that variable, mean, median, mode, variability, what kind of distribution that has, you'll be able to plot that. You'll be able to do so much analysis with that. Okay, so that is your descriptive statistics, which you already have gone through. It's not something new. Okay, you already have been there, done that. Okay, uh, all right. Now then comes the inferential statistics. What is inferential statistics? Why is that required for a data scientist profile? So as I said, you will be inferring from the data, right? The output that you get, you have to interpret, you have to infer from that, right? So maybe you've got certain p values, certain t values. There'll be a lot of tests, right? There's something called hypothesis testing, which includes various kinds of tests, right? And they're done in different situations. Why do you do that? What is confidence interval? How do you calculate it? What does it really mean? So to be able to interpret how a sample, say, so I'll give you one quick example here, right? So which will make you understand both descriptive and inferential, at least the essence of it. So suppose I am interested in finding the say average meal price across restaurants in Pune. Okay, suppose that is what I want to know. I want to know what is the average meal price across all the restaurants in Pune, right? Now I'll have to collect meal prices for various restaurants, isn't it? Meal price for, since I have got data for 1,000 restaurants. Consider there are 10,000 restaurants in Pune, a simple random number, and I've got data for say 100 of them. Consider them to be 100, right? Now this 100 meal point, the data for these 100 variables, or sorry, data for this variable meal price, and I've got 100 different data points there. That is my single variable. That is my, so to be able to understand how the data is varying, what is the maximum value, minimum value, what is the average price for those 100. Do I have some very extravagant values there, some negative values there? Do I have some kind of problem with that? So to be able to understand all of that, I'll be able to use descriptive stats. Okay, but this 100, using this 100 data points, I want to know for the entire 10,000 data points, right? For the entire population or entire restaurants in across Pune, right? So in that case, I would need inferential statistics. Inferential statistics will help me understand. So this is my sample. Okay, this is my sample data. I have drawn a sample of size 100 from a overall population, right? This is my population. Okay, population in statistics, let me explain that also. So when you talk of population, so population in general, we understand population means human beings, right? what is the population of a certain place. In statistics, when you say population, population is anything and everything which is fulfilling a certain criteria. For example, I wanted to know all students or all children or all students of class 5 in Delhi. Okay, suppose this is what I want. All students studying in class 5th in Delhi, uh, right? So that will be there'll be a lot of students. Say, suppose there are 1 lakh students, right, who are studying in class 5th in Delhi, right? Now all of that will become my population. Similarly, if I'm looking at all the average meal price of, or I wanted to say average height here, right? Suppose I say average height of all students of class 5 in Delhi. So height will be one variable. To be able to understand that variable, descriptive statistics will be required. That's one simple thing. Now, uh, here the population would be all the students of class 5 who are residing in Delhi. That will be my population, right? This is human being. Similarly, if I wanted to find average price of all the all meals, average meal price across all restaurants in Pune, so all the restaurants in Pune will become my population. So population need not be human beings, it could be anything. But here it is about everything. So the question is, I want to find average meal price. So everybody who's fulfilling the criteria in the question, that is my population, right? So now this population consists of say 10,000 values, right? But it's not possible for me to take all 10,000 data points and work with it, right? So I'll take only 100 data points, certain sample, and using that sample I'll try and predict how the population is going to behave. Okay, I'll try and understand how the population will behave based on the sample data, and for that I need inferential statistics. Clear? To be able to infer. Did I make sense, everyone? Anybody who has not understood this? Quick yes, no? Okay, I think we are good. Great. Uh, all right. So this is your technical skill, right? So statistics is one of the technical skills. Okay. Shubham, you'd asked that sometime back. So descriptive stats, inferential statistics, then you need algorithms, right? Machine learning algorithms. Now, again, there'll be a class on machine learning later on. If you wish, you can attend that also. So in this session, I'll not go too deep into machine learning. Just understand machine learning is a set of algorithms which will be used to create models, to be able to create models which is used for data modeling. And you will be using these algorithms which are pre-built kind of algorithms like linear regression, you have decision trees, random forest, bagging, boosting, clustering, various techniques are there, right? So you'll be using those techniques to model your data, to be able to find patterns in your data. So machine learning is very important to a data scientist, right? Inferential stats, machine learning, and descriptive statistics, all of them are very important for a data scientist profile. Okay, must have skills. You cannot say that I don't know this. You'll not be able to become a data scientist without that. Okay, now coming to the other spectrum of it. Okay, so now again, technical skills. I'm just continuing with the technical skills, that is good. So in terms of business skills, you need to be able to visualize data, which is create reports. You need to understand the domain. If you know well and good, you should be able to understand business, right? So business acumen, the problem solving ability, the domain knowledge, and be ability to communicate well, right? To be able to create visualizations, to be able to communicate whatever you have figured out. That is your business knowledge, right? In terms of technical knowledge, it is your statistical understanding and the tools. Okay, now I generally encounter this question in this slide very commonly, that do I need to know a very good do I need to be a very good programmer to become a data scientist, right? So frankly speaking, the answer to this is no, right? You do need programming. It's not that you don't need programming, but it's not that you have to be a very good programmer. That's certainly not, that is not your as a see, understand, data science has been practiced by people who were statisticians, right? I told you statisticians were doing this stuff earlier, right? So statisticians were never programmers, right? Those people were more into mathematics and less into programming. They were doing a bit of programming, but pretty less of it, right? As compared to you and me who have done programming earlier, right? So when you talk of data science, you do need programming skills. That is required because you are handling so much data. So to be able to handle data, you need programming skills. And if you know programming well, right? Again, the extent to which you know programming will obviously be helpful, will be important. But without programming, you cannot become a data scientist. You'll have to do a bit of it, but that is pretty minimal, right? That's not really too huge that you're not really able to get into data science without that, right? So you can very easily learn programming. This is very simple programming language, and you'll be able to do well with this. Now, coming to this, right, tools, again, I'm explaining all of that. So there are various tools which are required as a data scientist, right? Um, you need to know at least one of R, Python, SAS, at least one of them. SAS I would not really recommend now, primarily because SAS being a paid tool, the usage of SAS in the market is more or less restricted to only banking and financial industry, where they're trying to incorporate a lot more of sorry, they're trying to incorporate a lot of R and Python into the analysis, right? And the only reason being that when you're working with data science, or when you're working with SAS, that's primarily a paid tool, and companies really don't want to spend a lot of money on the tools now when you have good freewares available. So R and Python are both open source freeware technologies which are readily available in the market, right? You can go to Google, download it, and start working with it. Right? It's as simple as that. And they have far better capabilities when you compare that with SAS now. So that is one of the reasons R and Python have become the most important tools for data science. These two are the most commonly used tools for data science, right? Again, there's a question: should I go for R? Should I go for Python? This is a very debatable question. Many people feel R is better. Many people feel Python is better, and they have their own their own justifications to that. Some of you would, we would agree to some of them. We would not agree to some of them. So, but if you look at the bigger picture, if you look at the jobs and stuff, which is what you're trying to get into. So I would say I would rather suggest you go with both the tools. Don't jump into both the tools at the same time. Start with one tool and go to the next tool, right? So you can start with any one tool. You can start with R, you can start with Python. If you're somebody who's from a non-programming background, still you can start with R. R is easier to learn. Many people say that R has a very difficult curve, but frankly speaking, R is very, very easy to understand. And tomorrow I have a session on basic hands-on on R. So you can very well come back and attend another session tomorrow. I'm sure many of you have got the links to that session as well. So that will be a hands-on case study session. Come back into that session. I'll tell you how easy R is, right? And again, Python is again simple, broken English. It's like English. So again, Python is also easy. But having said that, if you're not, a lot of people have just this, apprehension to programming for whatever reasons. You've never done that, so you have a lot of apprehension. So don't worry about it. Both are pretty easy. Both are pretty easy to work with. Either R or Python. I would suggest you take both the tools. That will open up many opportunities in the market for you. And it's not that if you do only R, you'll not get opportunities, or if you do only Python, you'll not get opportunities. The only difference would be the number of opportunities that come your way might reduce a bit, right? In all the job description profiles, you would see R and Python, R/Python. They would write R/Python. Right? Very few will have SAS as well, but R/Python is very common in all the JDs for a data scientist profile. Okay, so that is one tool which you'll be needing for cleaning, transforming, modeling the data. For applying machine learning on data, you would be using this tool. Okay, then at least one tool for collecting data, right? So to collect data, you need to understand SQL. Now it's not that if you have to collect it all the time. For a data scientist, you generally have big data engineers who help you with that, who help you collect data, who help you build that entire pipeline and work with that. But the only problem is you should not be dependent on somebody for just data, right? Basic SQL you should know, basic intermediate if you know, that will help you in manipulation also, that will help you in other aspects of data handling as well, right? So basic intermediate SQL if you know, that will help you in data collection and a bit of manipulation as well. And that is something again you'll be learning in the course, right? So that's a complementary module for people who are not aware. MS Excel again, not just to showcase your comfort with numbers, but also, you know, Excel as the is the kind of, you know, is the go-to tool for anybody who's doing data analysis. So by default, people open your Excel for analysis. So you should know at least formulas, at least pivot tables in Excel. I'm not expecting you to know, you know, advanced Excel. You know, you need to know the VBAs and the macros and the automation of that. You don't have to worry about that. That's not required because we're not using Excel for all of that, right? We're primarily using you know, Excel because if need be, you can do a bit of analysis on data. You'll not try and, you know, take the entire chunk of data on Excel, because Excel will hang up. It will not give you the output, and that is not what we are expecting. That is where we're using R and Python. Excel has limitations in the amount of data it can handle, amount of data it can process, and the speed at which it can process. Because of those things, we're using R and Python, right? Okay, so people from non-programming background can also learn R and Python. Pretty easy to go ahead with, pretty simple to learn. Mm, Statistics will play a part, and then SQL and Excel. These three are important thing. Plus at least one visualization tool. Why do you need visualization tool? I was saying some time back that you need to be able to put out your data to business in the form of a report, in the form of a uh, of a chart or a graph, because business won't understand your complex equations, right? They would not be able to interpret what is happening, so they would want your tableau or ClickView, some kind of report which they can refer to and then work with. Okay, all right. Now, any questions till this point in terms of statistics, in terms of tools? What is data science? Difference between big data, data science? Why are we talking of data science now? Any question? Anybody? Types of descriptive types of statistics that you have, analytics that you have, sorry. Any questions, anyone? I'll come to the opportunity part, right? Whether you, how do you transition, uh, which one do you transition to? So Siddesh, I hope I've answered your question. Even when you're not good at programming, I think you can start with R or Python. R is pretty simple to understand. So you, not expecting you to know statistics right now. All of that will be taught in the course, right, Shiva? So not really expecting you to know all of that. It's that when you go out there for a job, is what you would be requiring is what I'm trying to tell you now. So when you try and apply for a data scientist profile, what kind of skills people would expect from you. Okay, I'm getting a lot of questions here. Uh, okay, I'll try and answer whatever possible, right? So what kind of statistical will be applied? So you'd need all the statistics. Basic also you'd need to understand one variable, because when you take a set of data, you need to explore the data, right? For data exploration, exploratory data analysis, you use descriptive statistics. Can to be able to understand which parameters or which factors are important in your data, a lot of inferential statistics will be required, right? And again, when you model it, then inferential statistics will play a key role. Machine learning is by default, you know, that is the thing when you work with data science. So all the three things will be important there. Okay, I'll talk about the one more thing. How do you transition? So just hold on to that for some time. I'll just take a few questions and come back to that thing, that how do you transition to data science. Difference between data science and data analytics. Okay, so when you talk of data science is the entire pipeline, right? So told you business problem, data collection, or let me just see if I have that slide here. One sec. Yeah, so see, this is entire data science pipeline, right? Uh, and this part, when you build the model, when you create this, that is your data analytics. Now this could be reporting, this could be predictive analytics, this could be descriptive analytics. The entire thing is data science. So it is the bigger picture, which is with data discovery, data preparation, data modeling, uh, right? So model planning first, and model planning, model building together would be data modeling part, right? Data modeling, communication of results, and then putting that into production. All of that combined is your data science. Data analytics is only the analysis part of it. So it's a subset. It's a process within that. Clear? Okay. Uh, then I have another question. Do we have to learn complete Python, or some modules are good enough for us, please? Okay. So see, when you work as a data scientist, basics of Python, obviously you need to understand how basics work with Python. Plus, you need to understand certain certain specific modules like NumPy, Pandas, uh, all those things, scikit, you know, there are a lot of things, right? SciPy, all of these are various libraries which are used for uh, for data science, or for so Python per se is a generic programming language, right? You can do anything in Python, and you have certain specific modules for data science in Python. You need to know that. Okay, that is something which will be required. Again, not everything you can know. In data science, there'll be certain limitations. When you start, focus on building a very good solid platform, right? If you are able to build a good solid platform in data science, so understanding machine learning, basics of it, right? You don't okay, a lot of people, on the very initial days, I've seen people getting into, okay, let me do text mining, okay, let me do big data analytics, let me do TensorFlow, let me do deep learning. I would refrain you from doing that. I would ask you to refrain yourself from doing that. Don't jump into all the things and try and cover everything on initially, right? You first of all, you need to understand what it is, understand statistics, ML properly, solve at least 4 5 10 projects in that, do some case studies. Once you feel confident about, okay, now I know these things, I'm pretty good at it, then you go ahead and then up learn the, I mean, once the foundation is laid, then you can build any kind of structure on top of it, right? It could be, it could be big data analytics, it could be text mining, it could be image processing or deep learning, or whatever you name it, right? All of that is possible. But if the foundation is not there, all of that will shake up in pretty quickly. So I would say that focus on the basics, right? Now another question, do okay, one sec. uh, okay, one question is, what is the scope for freshers in data science? So frankly speaking, when you are saying you're fresher, if you go out there and saying I don't know anything in data science, nobody's going to hire you, right? Again, if you're hired in college, they see a bit of what you already do. Are you so they might hire you based on your understanding. So there in colleges also, now, I mean, now we're not hiring in just plainly because you're good problem solver. Earlier, say 2 years, 3 years, 5 years back, say I think 5 years back, there was a lot of hiring which was happening only if you are good problem solver, we would take you, right? And I've done a lot of hiring for data scientist profile as well. So I understand that part. Now, as people are aware of it, a lot of people know it. We want to look at your projects, right? When I go out to hire somebody, I want to know, okay, what kind of projects have you done, right? And can you really talk about those projects at length with me? Why did you do that project? What kind of an output was there? So your CV does not only need to have, you know uh, only need to have some kind, I mean, even if you are fresher, right? If you're in college, you need to do at least 1 or 2 or 3 projects in data science, and then you need to be able to talk about it. If that is there, I believe that you and you're able to convince me or the interviewer that you have actually done it. So the shortlisting is primarily done on the basis of the projects and your effort in that. Freshers have a better chance because you still are learning, right? You are in that learning period. So a lot of people would be ready to invest in you. That's one part. Second part, you would not really be charging the very high salary. Again, that is the second part, that is where freshers will be preferred over the experienced people. Again, experienced people will come with a lot of other skill sets, so they come with that. So again, both have their pros and cons. And again, based on the need, you would try and hire, but the hiring happens for both of them. Freshers are also being hired big time in data science. Would you suggest learning Python and R parallelly? So I would say when you start with one tool, get yourself comfortable with one tool. Take a month, 2 month, get yourself at least that much that now you know R or now you know Python, and then you do Python, right? Or take one tool at a time, then the other tool after a month or 1.5 months. Once your basics are laid out, that is how we also do in our course. We don't give you both at the same time. That will be a make it a khichdi. That will not really be what you're looking for. They'll not add value. So at the end of the day, it has to be a lot of value addition which has to happen in your profile, right? So with that only you'll be able to do well. Okay. Okay. Okay, I'll come to the career specific questions in a while. Okay. So let me tell you how to transition. What is it that the that I'll be looking at when I hire somebody, or what is it that the industry looks at when they hire somebody, and how exactly the transitioning is possible for people who are fresh and who are not really working in exactly data science. How does that work, right? So that is what we'll try and explore in the next slide. So, so I'm talking about the transition, right? So people who are pretty fresh in the industry, right? Who are less than 4 or 5 years in the industry, you need to be able to work with data science. You need to be able to showcase that you know data science, right? To some extent, it might not be a very deep expertise in data science. You're not really expected to know that. If you know it, nothing like it, right? You're hired then and there. But the expectation I'm talking of, if you're less than 2 years, 3 years, 4 years, your expectation from a data scientist or for somebody who understands data science would be more of the conceptual knowledge. Plus, again, I'm saying the projects would be the key, right? Projects, if you can showcase say one or two good visualization, you have done some kind of stuff. How good are you communicate with communication skills? How good are you with problem solving abilities? Uh, so there are 3, 4, 5 skills I talked about, right? So from people 0 to 5, domain does not really play a very important part there, right? Your previous experience would play a part. Uh, I mean that will be considered. So you would come. So somebody who's working with SQL, that is important, as that is pretty close to what data scientist does. uh, if you're doing ETL, right, again you're closer to data science because you've been working with data, you're working with databases, working with AWS, you're working with some kind of Python or some programming language. So all these people who are closer to data science, they will have that weightage of 20%, 10% in the resume. You come with say team player, you are a team leader, you are a project manager, you understand handling, client handling, project handling. There's so many things, there's so many skills, right? So if you bring whatever skill excuse me, whatever skill you bring to the table, that is handy, right? It's not that your skill is wasted. Or if again, this question comes to me very often here, that okay, I've been working in some other industry for past 6 years. How do I transition to data science? Will my previous experience will be counted or not counted? How will I show that up? So it's not that. What is important is that whatever you have been doing, right, most of you will be able to relate to data science, right, in some or the other way, whether it is sales or marketing or anything, right? It's important that you showcase some kind of analysis in your profile, right? You don't showcase that data science has come on into a profile out of the blue. You were doing something and suddenly you became a data scientist. People would not really feel very comfortable with that kind of a profile. There has to be a story, there has to be a logical transition, right? So suppose you're working with data science and you say, I've been working with XYZ, say in a project. In your project, are you using some kind of prediction? Are you using some kind of analysis? Is there any kind of report being generated in the entire business, right? Whatever business you're working with, whatever client you're working with, try and understand that part. And what we really try and do in our course also, we give you a lot of case studies to solve, right? During the course also, we teach you through case studies. After the course, we give you case studies to solve, and when you solve those cases, then you start learning a lot of things. A lot of things get imbibed, right? A lot of practical aspects come into picture, and that is where your transition will happen, right? It should not be that suddenly out of the blue you say, okay, I was working with Java, one day I felt like working with data science, and I started working with it. So there has to be some kind of a connection that needs to build. A story has to be brought up. Only doing a course on data science, whether it is a short-term course or a long-term course, would not really help. Again, I'm saying it has to be a logical conclusion, right? That will help you. people with more and more experience, domain comes into picture, your other ability comes into picture, other skill sets will come into picture, and that will help you transition. Okay. uh, all right. If I Okay, I have a question here. Okay, couple of questions here rather. So I'll try and answer a couple of questions here. So I see, if I do PG diploma in big data analytics from CDAC, is it worth doing? See, I really don't know how CDAC does it, and I don't know what is the duration. I would say if you are trying to learn data science, you should not spend more than first 6 months, 6 to 8 months. So you should try and make sure that you get into a job in 6 and 8 months. That is that is what will I mean that the learning on the job would be far more helpful than doing an entire end-to-end course on data science. So I would not really recommend a 2 year or a 3 year diploma course. In India, we have this ability, or that fascination towards degree, that okay, let me do a degree that might help. More often than not, it is not really helpful, right? So what I would suggest that, uh, at the end of the day, in any of the courses that you do, right, 2 years, 4 years, they'll be giving you a lot of things. It's not that they'll not be giving you things. They'll be giving you, teaching you a lot of things. But do you really need all of that initially in your career? I think no, right? So the answer to that relies that you don't need everything on day one. You need certain bare minimum important foundations. If you are good with that, if you can showcase 2, 3, 4, 5 good projects in your case, that will be far more valuable than doing, than you're a PG or something from some kind of an institute, right? So I would always suggest, uh, okay, so it's a 6 month course. Okay, so even then, again, you need to see what they are giving you, how much they're charging, what is it that they're teaching you. Accordingly, you can take a call, right? So frankly speaking, I don't know how much CDAC teaches, but most of the institutes, right, I've seen, they're charging you a lot of money and giving you a certain very limited value in that. So you'll have to look at that. Okay. I want to switch my career to data science, analyst or data engineer from assistant professor. Which certificate course I want to pursue? Which company's career I want to look on? Okay, a lot of questions in one go. Okay, I'll try and answer that question towards the end, Sumud. Okay, that's one specific question you have. All right. So this I talked about data science project pipeline, uh, which is how exactly data science, pipeline works, right? So there's the various phases to a data science project. You start with discovering data. You go and do data preparation, which is exploring the data, make the data good enough for you to be able to work with that. Then you create models and build models. Then you communicate, and once and it's a so here there are a lot of loops here, right? Which means it's not a one-way process. It is a very iterative process. You can go back from the fourth step to the first step again. It can happen, right? If you're not satisfied with the model, if the accuracy of the model is not good enough, you might want to go back, right? Then communicate results and operationalize. Okay. All right. Now let me just quickly talk to you about what we offer at Dimensionless. What kind of courses do we run, and how exactly we run it? Okay. So as I mentioned, we are a group of IIT graduates. I'm an IIT Delhi grad, with about 10 years in industry. So I bring all that experience of mine from the industry, which has primarily been into predictive analytics. So I try and bring all of that into the industry perspective here, and try and the course has been created with that kind of a background, understanding that you when you go out into the industry, people are not really looking at your theoretical knowledge. They want to know how much you know, practically, right? What kind of practical aspects you bring to the table, and if I give you a problem, will you be in a position to solve it? Okay, those things are something which we have uh, certainly looked on to. Okay, now what is it that we cover? So our course is data science with R and Python, and data science with R or Python, right? So you can I take one tool out of, instead of taking both the tools, you can drop a tool. That is possible. But as I said, if you're looking for a lot of opportunities in the market, I would suggest you take one, and then in the same course, after a gap of about 50, once you learn R, then you do machine learning with R, then you learn, say, Tableau. So that gives you a gap of around 15-20 days, 1 month. Then you start from Python basics, and then you do machine learning with Python. So that gives you a 1.5, 2 months a time frame in which you're learning two different tools, and hence you are able to manage that. Okay. Okay. So coming back here, so we teach you everything through problems and cases, and all our sessions are are live instructor-led sessions. So we don't teach you a lot of theory in class. Everything is driven through problems and cases. Okay, and all the sessions are held live. Okay, it's a live online training. That is something which you should understand. And only reason for online is I don't, I mean, it's difficult for, for best faculties to be present, or good, good faculties to be present at a given location at a, all the time. And I really don't want, I mean, maybe I am traveling because of some issue, but I don't want to make, I don't want to make sure that you suffer out of it. So I can take the session from anywhere I am, right? So that is something which is really helpful or handy in online, right? And again, the we don't take more than 10-15 people. I'll talk about that. So this is primarily a live online training with a limited batch size, very limited batch size. uh, I'll talk all of that. Just give me some time, Manik. Uh, so limited batch size, right? So uh, batch size is limited to 10 to 15 people only, so that we are able to give personalized attention to every individual. Okay. Uh, Now, since this is live online classes, all the sessions are recorded, right? So sessions are recorded, and recordings of the sessions will be available to you throughout, right? So for the next 2 years, you can access the recordings. Okay. Um, all right. Since this happen live, so they will happen at certain times, right? Correct. I mean, because suppose I am training you now, the session is happening from 9 to 10:30 p.m. Similarly, class will happen at a certain time where I'll be talking to you, you'll be putting up questions, you'll be interacting with me all the time, right? So that is how it will be. So it's either 7 a.m. to 9 a.m. in the morning, Monday to Friday. That's one kind of a batch I have. The other is weekend batches, which is 10 a.m. to 2 p.m. or uh, 3 p.m. to 7 p.m. Sorry. Okay, these are the two kinds of batches which happen on Saturday and Sunday. This is Saturday and Sunday, Saturday and Sunday. Okay, so 7 a.m. to 9 a.m. Monday to Friday, this is one. Okay, there you do about 10 hours per week. So you do about 10 hours per week, thereby you do for about 3 months. Weekends you do 8 hours per week, thereby you do about 4 months here. Okay, all right. Uh, Coming back here now, what is it that we teach? I told you everything is problem and case study driven. So you're taught, uh, okay, you're taught descriptive stats, inferential statistics, uh, right? And the duration is mentioned here. Somewhere around this much time we'll be spending on each of that, and the tools will be using this. Approach will always be problems and cases. We don't really teach you theory directly, right? We want you to do a lot of hands-on. So all the sessions will be hands-on, right? You'll be working on the problems throughout. Okay, R and Python, any one tool or both the tools. Machine learning, this is the most important aspect of a data scientist profile. We spend a lot of time here, right? Good 50 hours of the course is spent here. And here you'll be doing at least a couple of case studies for every algorithm. So you take one algorithm, do a couple of case studies, understand how it is done, go back and solve one case study back home as well. That's given as assignments. Come back and the next algorithm will take and we'll work with, give you more case studies on that, right? So you'll learn a lot of case studies during the course also, and post the course also will be doing it. Tableau again, which is a data visualization tool, we cover Tableau here, which is about again 18 to 20 hours. Then SQL about 10 to 15 hours. This is primarily a complementary module for people who are not really aware of it, right? So uh, that is one. uh, R or Python from the very scratch, you'll be spending about 30 to 32 hours, right? Once you're done with this, this is about 130 to 140 hours of training. 130 hours of training, sorry, 130 hours of training will happen in about, as I said, 3 months or 4 months, right? If you do one tool. If you do both the tools, that becomes about 170 hours, right? So just add four weeks for weekdays, one more month, and 1 month for weekends, right? So that will be that much increment will happen in the overall duration of the course. Once you're done with this part, right, then comes the real transitions impact, right? Because as I said, if you have to transition into data scientist role, the transition will happen only when you are able to showcase your profile, you're able to showcase that you know data science well. and that is where your transition will happen. Otherwise it will be very, very difficult. So you need to showcase projects, case studies, and post the course will be giving you real-time cases to work on, right? You'll be getting one case at a time, and when you work with one case, there'll be problems, challenges you'll face. We'll be there to support you. Plus, after you've done that case, we'll be discussing that case for about 4 or 5 hours, right? Then you take the next case, we'll be discussing that. Then the third case, we'll be discussing that. Then the fourth case. So you do 4 or 5 such case studies, and that is where your profile will be built, and that is where what you will be putting in your resume. Will be helping you with placement assistance, with resume preparation, and all of that. Okay. So there'll be another 20 odd hours of discussion post the course also. Okay. All right. Uh, Coming back, why you can choose dimensionless. So our sessions are very interactive. We allow you to speak in the session. Right? Today I really did not allow because in a demo session, not everybody is very sincere. So a lot of times I face a lot of disturbance. So I generally keep you on mute. So, but in the regular classrooms, I think Shiva is here, who is a referral student. So some of Shiva's acquaintance has done a course with us. So Shiva is coming in only on that basis. So he can vouch for it. He can explain you that. So it's a very limited batch size that we take, not more than 15 people. Very interactive session, making sure that you are with us all the time. A lot of hands-on will happen. All the faculties are IIT grads, very experienced, having a lot of strong analytical background, right? And will be available to you for any kind of questions or problems that you might have. Will be approachable. Okay, that's something which is very, very important for us. Then after the course, there'll be support for at least 1 year. If you have any questions, problems, you can come back and ask us. We'll not say no to that, right? All the sessions are happening live, and the recordings of the sessions are available to you lifetime, right? Lifetime means at least couple of years, which is by that time you know data science would have changed, things would have changed, right? And whatever you would have learned so much that you really don't need these recordings. Post that, um, there'll be if you miss any session, you are bound to miss sessions because of some or the other thing. uh, so what we do, we would allow you to attend live sessions again in some other batch, right? So you're allowed to attend live sessions in other batches also. In terms of placement assistance, we have certain things. So I told you, one is we need to create a story in your profile, understand what your profile is, what you have been doing, and accordingly we'll be creating a story, right? We'll be helping you build your resume. So we'll be sitting with you for some time, and uh, then once you understand your profile, we'll try and see what kind of background you come from, what is your experience, and accordingly we'll build a profile for that, right? We are from IT, so we have a decent amount of network in the industry, which we have built over a period of time in the industry, and through our colleges as well, and we use that to get various requirements from the industry. Okay. Many times the companies will give you case studies when you go for interview. So they'll give you, I mean, they'll take a telephonic round. If they're okay, they'll give you one case study, solve it in a day or two, and send out the results, right? So we'll be there to help you with solving those cases as well, right? And as I said, for us, capstone project or real-time case studies is very important. That is why we just don't give you one. We want to give you at least 5 case studies. Okay. Then you'll have access to the online lab, which will look like this. So where you'll have videos, assignments, data sets, problem sets, books, white papers, and whatnot, right? So you name it and you'll have it there. There'll be an online lab also. We'll be working on that online lab tomorrow. If you wish, you can come tomorrow's session also well, and you'll be able to get a good hands-on on the lab as well. Understand our basics at least. Okay. All right. Now I have a few questions here. Uh, Let me take those questions. Okay. Now, do I need to get a certification? Again, I'm saying, when I look at, or I've been there for quite some time. We okay. If I see a certificate, that is okay to me. That's not something which is extraordinary. Getting, because there's no industry body. It's not a certification which is coming from, say, Microsoft or an SAP, where there's a stringent test which is happening, and on the basis of which you're getting a certification. That is not the case, right? In data science, there's no industry body which is certifying you. So whatever certificate comes up, you know, all the certificate you take, XYZ certificate more or less has the same value, because there's no industry body which is certifying you, right, at the end of the day. So, and that is where the essence of data science certification is not really that high. Again, I'm saying the focus has to be on the learning part. If you learn things well, you will be able to uh, you'll be able to no, the sessions will not be uploaded on YouTube. Okay. If you learn the sessions well, you will be able to sorry. Okay, if you learn the sessions well, if you understand, solve the problems well, if you put in the projects, that is where your transition will happen, right? So I was trying to tell you that. Again, there's a question in terms of fees. So the fee structure is for if you take one tool, it is 30,000 rupees. If you take both the tools, it is 35,000 rupees. So there is both R and Python, and this is only R or Python, any of the two, right? You can take any of the two, and the fees will be 30K. Duration will be, this is 170 hours of live training plus 20 hours of case study discussion plus other discussions, which I'm not counting here. This will be 130 plus 20, right? This much bare minimum you'll be working with me. Uh, Now this is inclusive of taxes, right? The fees is inclusive of taxes, so that includes 18% GST, both the fees, right? This as well as this. You don't have to pay the fees on day one. You have to pay 5K when you register, and once you pay 5K, you will be able to get started with data science, right? There's another thing which is coming up pretty soon, where we are charging 1,500 rupees for 5 sessions of seven in about 8 to 10 hours, and there I'll be taking you one case study, and giving you the entire uh, how do you work with a single case in data science. So you'll be able to do that in 10 hours, and that is happening maybe next week, or next week probably we'll have those sessions, but that is charged, right? That is around 1,500 rupees for those 5 sessions, right? So that is also, but in if you join the course, that 1,500 will be deducted from the overall money that you have paid, I mean overall fees. When you start by paying 5K, the first installment, and then you are allowed to take 2 weeks of sessions. With that, you will be able to judge us much better in this 20 hours of sessions, and then you pay us the rest of the amount, right? Which is again, payable later. Now, in terms of fees, I think I've answered that. We don't have sessions in the evening because many people are from, in the working. Most of our students are working, and you tend to miss a lot of sessions because some or the other work generally tends to come up in the evening, and you're not back by 7:38, and it becomes very difficult to give you things, because I at the end of the day, for me, it is important that you learn. If you're not learning, your effort, my effort, your time, my time, everything is getting wasted, right? So we need to reach a conclusion. We need to get to achieve an objective, right? That objective could be a job, could be transitioning into some role. All of that should be achieved, right? So, and that will be achieved only when you know data science well, right? When you have solved a lot of questions. Okay. Okay. Any other question anybody has? Fee details I've mentioned. Evening batches I've mentioned. Placement support. Okay. As I said, there'll be a lot of placement support. I mentioned that here. So once you're working with the case, I'll be helping you through my referral network. So every day, I get a lot of inquiries. Uh, Okay, you'll be able to get. I'll be okay. So first, let me answer this question. So I'll be helping you with resume preparation. As I said, I'll be understanding your profile, making you do 3, 4 case studies, building your profile on that. Right? If you're working in a certain domain, you'll be solving at least a couple of cases on that domain. That will help you. Uh, that will help you get into data science easily. Right? Now, through our referral network, as I said, I'm getting a lot of inquiries every day. I get at least 2, 3, 4 requirements from the industry, which I post to my students, right? Uh, and then you will also be getting those mailers, and you can directly apply it there, right? Plus, I told you this, many companies give you case studies, so we'll be helping you with that also. So there'll be a lot of placement support which will happen from our end. We try and make sure that you get placed as soon as possible. And again, you have to be sincere with your efforts. And if you're sincere, I mean, you get a lot of interview calls. That's not really a lot of problem. So if you want to see data analyst to data scientist, see these are two different profiles within data science, right? So data analyst is a person who is doing simple analysis on Excel, or who's only doing say visualization with Tableau. Just consider that's one profile. You can directly I mean, if you learn all of that within the company, you can always get to a data scientist profile within the company, right? Maybe 1 year, 6 months, 2 years. It's not that if you do a course you will directly be hired as data scientist. That is not the case. There are certain companies which hire you directly as data analyst, some will hire you as data scientist. But if you know data science, right, if you know predictive analytics, they would make you do that. Why would they just keep you for Tableau, right? Maybe you do it for a month or two and then you move towards the data science pipeline, which is predictive analytics, right? And that is where your value would be. And then once you're doing that, next company you can always go in 1 year also, you can go and say I know data science, and people will hire you. Okay, then there's a question: if I miss a session class in the morning, will this class will be recorded? Will I be able to get the recorded session on the same day or next day? Sure, generally you'll be having one set of recording, right, which will be available to you anytime. The same recording, the session that we are working with, that might be available to you same day or the next day, right? Latest by the next day, you should certainly have it. Okay. All right. Any other question, anyone? All right. Seems like we are good. You can always always reach out to us on these numbers, and uh, we will always be happy to help you, right? um, okay, so there might be a feedback form which might be sent out to you maybe tomorrow or day after. Please do fill that form, and we'll be happy to improve on whatever aspects you felt were missing. Timing remains the same for the session again tomorrow, correct? And in the mailer that has been sent to you, the that is mentioned once again. Okay, so you can always go through that mailer, you'll have the link to that session. But tomorrow would be not a lot of gyan, it will be all practical aspects. I'll be taking you through a real-time case study. Okay. All right, great guys. So thank you so much for attending the session. Hopefully you were able to add a lot of value to yourself, and now you'll be able to take a better decision in data science, right? So that was primarily the agenda, and hopefully we have been able to do that. Okay. So on that note, I'm signing off. Hope to see you tomorrow once again, and we'll be able to do more tomorrow. Okay. All right, guys. Thank you.